right, so let's go through these, or we'll just go through. Actually, we're going to have to go through each one of them because each one of them is unique. When we get to lenses, we're going to skip around a little bit because they kind of look the same as these. But always start your arrows from the tip. And we will try to keep these organized a little bit. So from the top of the arrow, first ray comes in parallel, reflects through the focal plane. You have a virtual ray, which goes in the opposite direction of the reflected ray. Second arrow, again from the tip, the second one goes through the focal point and reflects parallel to the principal axis. Again, it has a virtual ray which goes off opposite of the reflected ray. Now notice that the virtual rays diverge, so you'll never have an intersection of those. The real rays, so the rays that reflect off the mirror, converge onto a point, and that point is where the image is. So if I put a piece of paper right here, I would catch that image and it would be perfectly in focus. If I moved that piece of paper closer to the focal point or closer to the mirror, it would be out of focus. Moved it further away, it would be out of focus. So you could kind of move a paper back and forth until you found that spot. That's the focal point, or the focal spot of this mirror. Describe the image, upright or inverted? It's inverted. Compared to the original object, it's upside down. Is it enlarged or reduced? Smaller? Is it real or virtual? It's real. It's made with rays that actually reflect off the mirror. So when you're outside the outside the center of curvature for a for a concave mirror, you get inverted, reduced, and real. Now there's 4 different types of mirrors and lenses, and there's 5 points for each. So there's 20 different scenarios that you have to have in your head. Now a lot of them overlap. So really there's 7 scenarios that you have to have in your head, if you remember the rules. And you can always draw them. It takes a lot longer to draw them, so I prefer if you just got them memorized. For the second one, we are on the focal point, or rather on the center of curvature. Remember, focal point is here. Center of curvature is twice the focal point. All right, from the tip of the arrow, parallel through F. Through F, parallel. We also have virtual rays that come back apart from the reflected rays. Now, for these, virtual rays aren't going to mean anything. There's only one scenario with converging lenses that I'll see in a second. Once we have 2 that overlap, draw the arrow to that point, and then describe the image. Upright or inverted? Inverted, it's upside down. Enlarged or reduced? If you drew it perfectly, they're exactly the same size. When you're on the center of curvature, your image is the same size as your object. It's a rule. You have to know it. Real or virtual? It's real since the rays actually come back in that direction. Third scenario, between C and F. The tip. To the focal point. Image. As soon as you start getting inside of that inside of the center of curvature, the object gets larger than the image. The image gets larger than the object. Still inverted. So far, they're all inverted. There's only one scenario that it's not. Enlarged or reduced? This is enlarged. Inside the center of curvature, it's enlarged, and it's still real. Notice we're just following those same rules, the three rules. Parallel through the focal point parallel, and then if necessary, law of reflection. We got the fourth scenario. Parallel through the focal point. Now, can't draw through the focal point here. If I draw through the focal point, it doesn't actually touch the mirror. So I can't use that one. I got to skip it. So I move to the third scenario, which is law of reflection. So I draw from the tip of the arrow to the center of the mirror. Now remember, the center of the mirror is flat on the principal axis. So it's going to obey the law of reflection. It's a little bit tricky to do, but you find. In this situation, the image is it's not there. There's no place where real or virtual rays intersect. Now, this is really hard to draw because if you draw it just a little bit off, you may look way out in the side of the page and see that they intersect, maybe even off the page. But the rule is whenever you have the object on the focal point for converging things, this is also true for converging lenses, you don't get an image. And we'll look at what this looks like in the lab. When you're on the focal point, you have a converging mirror or a converging lens, you do not get an image. Take a look at the last one. What happens when you're inside the focal point? Parallel through the focal point. Guy always works. Now we can't go through the focal point again, because again, we don't hit the mirror if we go through the focal point. So we obey the law of reflection. From the tip to the middle, and law of reflection. Now here's where it becomes important to draw the virtual rays. Virtual rays go backwards from the reflection. What happens here? The virtual rays intersect. So describe the image. The image is upright. Compared to the original object, it's the same orientation. So it's upright, enlarged, virtual. Oops. I need to use one more of these. you can get away with not memorizing this chart, but it certainly speeds up the process if you will. Five possible places that you can have an object. Object place. And then the chart will indicate what the image will look like. Now this is true for anything converging. For lenses and mirrors. We're going to confirm this with mathematics, and you can do that. And if you're really good at math, then it doesn't take very long to do that. But again, it's going to be a lot quicker if you just memorize. Outside C, the orientation is inverted. On C, the orientation is inverted. Between C and F, the orientation is inverted. That's nothing. Upright. So there's only one outlier in that column. Everything's inverted for converging stuff except for inside focal point. What happens to the size? True size. In the size column, it's outside C that's the outlier. And inside F is the only virtual image. That's true for anything convergent. We're going to do the same thing with lenses, and that's what they're going to look like. All the converging stuff is the same. All the diverging stuff is the next thing we're going to look at. And it's far easier.